Before the Big Bang, the universe did not exist in any form we can comprehend today. There were no stars, no galaxies, and no time itself. The concept of nothingness is perhaps the most challenging idea for the human mind to grasp. It is almost as if we are trying to envision a void that is devoid of all existence, a state where even the laws of physics do not apply. Yet, within this profound emptiness lay the potential for everything that would ever be, a tightly coiled spring of possibilities, waiting for the right moment to unleash its energy. Then, in an instant, that potential transformed into reality, marking the inception of the universe as we know it. The Big Bang began as a singularity, a point of infinite density and temperature, where the very fabric of space and time was compressed into an incomprehensibly small volume. In this singularity, all the energy and matter of the universe were contained, waiting to erupt into the vastness of existence. To truly appreciate the enormity of this moment, we must stretch our imaginations to their limits. This singularity was not just a point. It was the seed from which the entire cosmos would blossom, leading to the birth of galaxies, stars, planets, and eventually life itself. The moment of the Big Bang was not an explosion in space, but rather a sudden and rapid expansion of space itself. Imagine the universe as a balloon being inflated. As the balloon stretches, everything on its surface moves away from one another. Not because they are moving through space, but because the space between them is expanding. This is the essence of the Big Bang. Space itself expanded, creating the universe we inhabit today. In those first moments, the universe was unimaginably hot. Temperatures soared to billions of degrees, far beyond anything we can experience in our daily lives. At these extreme temperatures, particles such as protons, neutrons, and electrons could not exist in the forms we recognize today. Instead, the universe was a chaotic sea of pure energy, a swirling maelstrom of radiation and high-energy particles. As the universe expanded, it began to cool. This cooling allowed for the formation of the first particles. In the first few moments after the Big Bang, the universe underwent a dramatic phase known as cosmic inflation. During this brief period, the universe expanded at an astonishing rate, growing exponentially faster than the speed of light. This rapid inflation was so extreme that it stretched tiny quantum fluctuations over vast distances, creating the seeds for all future structures in the universe. These fluctuations would become the building blocks for galaxies, stars, and planets, laying the groundwork for the intricate web of cosmic structures we observe today. Cosmic inflation lasted only a fraction of a second, but its effects have echoed throughout the entire history of the universe. The tiny variations in density that were created during this period became the seeds for the formation of the first structures. Gravity, the fundamental force that governs the interactions of matter, began to pull together regions of higher density, causing them to collapse and form the very first building blocks of matter. Initially minuscule, these fluctuations grew over time, eventually giving rise to the galaxies, stars, and planets that fill the universe. As the universe continued to expand and cool, energy began to condense into matter. This cooling process allowed protons and neutrons to form, which then combined to create the first atomic nuclei. This process, known as Big Bang nucleosynthesis, began just minutes after the Big Bang. Hydrogen and helium were the primary elements created, along with trace amounts of lithium. These elements would serve as the building blocks for future stars and galaxies. However, the universe was still far from stable. For hundreds of thousands of years, it remained filled with a dense fog of hot plasma, which was opaque to light. Photons, the particles of light, could not travel freely through the universe until it cooled sufficiently for electrons to combine with protons and form neutral atoms. This pivotal event, known as recombination, occurred approximately 380,000 years after the Big Bang, marking the moment the universe became transparent to light for the first time. The light released during recombination is still detectable today in the form of the cosmic microwave background radiation, CMB. This faint glow permeates the universe, carrying vital information about its earliest moments. By studying the CMB, scientists have gleaned insights into the composition, age, and rate of expansion of the universe. After recombination, the universe entered what is known as the Dark Ages. There were no stars yet, and the universe was largely a cold, empty place. However, gravity was quietly at work, pulling together clouds of gas and dust. Over millions of years, these clouds began to collapse under their own gravitational pull, eventually forming the first stars. The first stars were unlike anything we see today. They were enormous, burning incredibly hot, and composed primarily of hydrogen and helium. These early stars, known as population 3 stars, lived short, violent lives. After exhausting their nuclear fuel, they exploded in powerful supernovae, scattering heavy elements like carbon, oxygen, and iron into the surrounding space. These elements would become the building blocks for future generations of stars, planets, and even life itself. The death of these first stars marked the beginning of a new era, the era of galaxy formation. Over millions of years, galaxies began to coalesce from the gas and dust left behind by dying stars. These galaxies collided, merged, and grew larger, giving birth to the large-scale structures we observe today. Galaxies are not just random collections of stars. They are complex systems held together by gravity. Within galaxies, stars are born, evolve, and die, contributing to the cosmic ecosystem. The interactions between galaxies can lead to the formation of new stars and the recycling of stellar material, creating a dynamic and ever-changing universe. As the universe continued to expand, the discovery of dark matter in the 20th century revolutionized our understanding of cosmic structure. Dark matter is an invisible substance that constitutes most of the mass in the universe, influencing the behavior of galaxies and galaxy clusters. While we cannot see dark matter directly, its presence is inferred from its gravitational effects on visible matter. It acts as a scaffold upon which galaxies form and evolve. Dark matter plays a crucial role in the formation of large-scale structures. It helps explain why galaxies are clustered together, as its gravitational pull draws them into groups. Without dark matter, the universe would look very different, with galaxies unable to form and evolve as they do today. Alongside dark matter, another mysterious force known as dark energy was discovered in the late 1990s. Dark energy is responsible for the accelerating expansion of the universe. This force remains poorly understood, but it is believed to be pushing galaxies apart, driving the universe into a faster and faster expansion. Some scientists speculate that dark energy could eventually lead to a scenario known as the Big Rip, where the universe tears itself apart in a catastrophic event, a fate that remains a topic of debate among cosmologists. The discovery of dark energy has profound implications for our understanding of the universe's fate. It raises questions about the ultimate destiny of all matter and energy, leading to theories about possible scenarios like the Big Freeze, where the universe continues to expand indefinitely, or the Big Crunch, where it might collapse back in on itself. The formation of our own solar system occurred much later. About 4.6 billion years ago, a cloud of gas and dust collapsed under its own gravity, forming the Sun and a disk of material that would eventually become the planets. The Sun, a medium-sized star, formed at the center of this disk, while the remaining material coalesced into planets, moons, asteroids, and comets. Earth, located at just the right distance from the Sun, became a cradle for life. The conditions on Earth were favorable for the emergence of life, with liquid water, a stable climate, and a protective atmosphere. Over millions of years, simple molecules combined to form complex organic compounds, leading to the first living organisms. Life on Earth began in the form of single-celled organisms. Over billions of years, these simple life forms evolved into more complex organisms through the process of evolution. Natural selection played a crucial role in this process, allowing species to adapt to their environments and thrive. The Cambrian explosion, which occurred around 541 million years ago, marked a significant turning point in the history of life on Earth. During this period, a remarkable diversity of life forms emerged, including the ancestors of most modern animal groups. This explosion of life set the stage for the development of ecosystems and the eventual rise of complex organisms, including plants, insects, and vertebrates. As evolution continued, mammals emerged and diversified after the extinction of the dinosaurs around 66 million years ago. Among these mammals were the primates, a group that would eventually lead to the emergence of humans. With our unique cognitive abilities, we began to develop tools, language, and complex societies. Our curiosity and intelligence drove us to explore our surroundings and seek answers to fundamental questions about existence. We looked up at the stars and wondered about the universe beyond our own planet. This quest for knowledge led to the development of science and technology, allowing us to study the cosmos in unprecedented ways. With advancements in technology, we began to send spacecraft into the depths of space, exploring planets, moons, and asteroids. Missions like Voyager, Hubble, and more recently, the James Webb Space Telescope, have allowed us to gather invaluable data about the universe. We've observed distant galaxies, studied the atmospheres of exoplanets, and even captured images of black holes. Each discovery deepens our understanding of the cosmos and our place within it. We've learned about the life cycles of stars, the formation of galaxies, and the nature of dark matter and dark energy. Yet, many mysteries remain, beckoning us to explore further. As we gaze at the night sky, we are reminded of our place in the vast universe. Every atom in our bodies was forged in the heart of a star, and the story of our existence is intricately tied to the story of the cosmos. We share this universe with billions of stars and galaxies, each with its own history and destiny. The universe is a tapestry woven from the threads of time, space, and matter. Each event, from the birth of a star to the formation of a planet, contributes to the grand narrative of existence. We are not mere observers. We are participants in this cosmic drama, shaped by the forces of nature and the unfolding of time. The universe continues to expand, and the future holds countless possibilities. Will we discover other planets capable of supporting life? Will we unlock the secrets of dark matter and dark energy? As we delve deeper into the mysteries of the cosmos, we are reminded of the importance of curiosity and exploration. The quest for knowledge drives us to ask questions, seek answers, and push the boundaries of our understanding. Each new discovery opens doors to further inquiry, revealing the interconnectedness of all things in the universe. The universe is a place filled with wonders and mysteries, and every new revelation brings us closer to understanding our origins and our place in the cosmos. Our journey is far from over, and the story of the universe continues to unfold. As we look to the stars, we are filled with hope and excitement for the future. Together, we will continue to explore, to learn, and to marvel at the beauty of the cosmos, forever seeking the answers to the questions that define our existence. Each day, as we peer into the vastness of space, we are reminded that we are part of something much larger than ourselves, a grand cosmic adventure that has been unfolding for billions of years. The universe is not just a backdrop for our lives. It is an integral part of who we are, shaping our understanding of reality and our place within it. As we contemplate the vastness of space, we realize that the stars we see at night are not just distant points of light. They are suns, many of which have their own planets, possibly harboring life. The potential for discovery is immense, and the thought that we might not be alone in the universe sparks both excitement and humility. The more we learn about the cosmos, the more we understand the delicate balance of forces that govern it. From the tiniest particles to the largest galaxies, everything is interconnected in a complex web of relationships that in our pursuit of knowledge, we are driven by an insatiable curiosity that has propelled humanity forward throughout history. This curiosity has led us to question the very nature of reality, to seek out the fundamental laws that govern the universe, and to explore the boundaries of our understanding. As we embark on this journey, we are inspired by the pioneers of science who have come before us, those who dared to dream and to explore the unknown. Their discoveries have laid the foundation for our current understanding of the universe, and it is our responsibility to continue this legacy. As we look ahead, we face challenges and uncertainties, but we also stand on the brink of exciting discoveries. The advent of new technologies, such as advanced telescopes and space exploration missions, promises to unveil the secrets of the universe in ways we have yet to imagine. We are entering an era of unprecedented exploration, where the boundaries of our knowledge are constantly expanding. The universe is a vast and dynamic entity, and as we unravel its mysteries, we find ourselves not only learning about the cosmos but also about ourselves. In the end, the story of the universe is a story of connection between stars and planets, between life and the cosmos, and between humanity and the mysteries that lie beyond our reach. As we continue to explore and discover, we are reminded that our journey is not just about understanding the universe, it is also about understanding our place within it. Each new discovery brings with it a sense of wonder and a renewed appreciation for the beauty and complexity of the cosmos. We are part of a grand narrative, a cosmic tale that has been unfolding for billions of years, and as we write our chapter in this story, we do so with the knowledge that we are all connected by the very fabric of the universe itself. As we move forward, let us embrace the spirit of exploration and inquiry that has defined humanity since the dawn of time. Let us look to the stars with wonder and curiosity, knowing that each twinkling light represents not just a distant sun, but a world of possibilities waiting to be discovered. The universe is a vast and mysterious place, and as we continue our journey through time and space, we do so with the hope that one day we will uncover the secrets that lie hidden among the stars. Together, we will continue to seek out the answers to the questions that have captivated our imaginations for generations, forging a path into the unknown and embracing the adventure that awaits us in the cosmos.